Hello students. In the first video on differential equations, we had seen the variable separable method to solve a differential equation. Today we are going to see the solution of a homogeneous differential equation. We are going to do some important examples, so watch the video till the end. First, let us understand what is a homogeneous function of degree n. Now just consider the following functions. The first function is y square plus 2xy. Second function is 2x minus 3y. Third function in x and y is cos of y by x. And fourth function is sin x plus cos y. Now just replace x by lambda x and y by lambda y. Then let us see what we can get. The first function f1 of lambda x lambda y is nothing but lambda square. If you take out lambda square, you can write it as lambda square into f1 of xy. Similarly, the second function f2 of lambda x lambda y can be written as lambda into f2 of xy. Third function is same, f3 of lambda x lambda y is same as f3 of xy. So you can write it as lambda raised to 0, which is 1. But fourth function you cannot express in such a way. So here functions f1, f2, f3 can be expressed in the form f of lambda x lambda y is equal to lambda raised to n into f of xy. But f4 cannot be written. So let us define a function fxy is said to be a homogeneous function of degree n if f of lambda x lambda y is equal to lambda raised to n into f of xy for some non-zero constant lambda. So here if you observe, f1 is a homogeneous function of degree 2, f2 is a homogeneous function of degree 1, f3 is a homogeneous function of degree 0. But f4 is not a homogeneous function. So now we have seen that f1 of xy we have defined as y square plus 2xy and f2 of xy as 2x minus 3y. Now in f1 just take x square outside. So basically it is x square into y square by x square plus 2y upon x. So y square upon x square plus 2y upon x. This is nothing but a function in y upon x. If you consider a variable called y upon x, y square upon x square plus 2y upon x is nothing but a function in y upon x variable. And outside I have x square. So how I have expressed f1 of xy? f1 of xy is expressed as x square into some other function, say h1 of y by x. Similarly, suppose if I take y square outside, then I will get y square into bracket 1 plus 2x upon y. So now 1 plus 2 into x upon y is a function, some function in x upon y variable. So again I could express f1 as y square into some function of x upon y variable. Same way for f2. f2 if I take x outside, I can write it as x means x raised to 1 into some function of y upon x. And if I take y outside, I can write y raised to 1 into some function of x upon y. So basically if I have a function fxy, it is said to be a homogeneous function of degree n if f of xy is equal to x raised to n into some function g of y upon x, or alternatively y raised to n into some function h of x upon 1. Now see, the first definition and second definition, both definitions are for homogeneous function of degree n. So these are the alternative definitions of a homogeneous function of degree n. So now for a homogeneous differential equation of degree n. You know that a differential equation is of the form dy by dx is equal to some function f of x and y. This is said to be homogeneous if fxy is a homogeneous function of degree 0. We have just now seen what is a homogeneous function of degree 0. So now let us see an example. X minus y dy by dx is equal to x plus 2y. Now this expression, first of all, our differential equation is of the form dy by dx. So just try to express in the form of dy by dx is equal to x plus 2y upon x minus y. Now we have studied two definitions of homogeneous function. We can use any one of them. Let us see both of them. Now suppose if I take f of lambda x lambda y instead of xy, then if I simplify it, lambda will get cancelled, so it is nothing but f of xy. Means basically it is lambda raised to 0 into f of xy. So it is a homogeneous differential equation of degree 0. Alternative definition, second definition which we have seen, in that what we do is either we take x outside. So if we take x outside and then if we simplify it, we can write it as x from numerator and denominator is taken out, so it will get cancelled. Into bracket you will have 1 plus 2 into y by x upon 1 minus y by x. So this is nothing but a function in y by x. So we have expressed our function fxy as x raised to 0 into some other function g of say y by x. Similarly, if I take out y outside, I can express it as y raised to 0 into some function h of x by y. So you can use any definition to show that the given function is a homogeneous differential equation. Only thing is it should be a homogeneous function of degree 0. Now these are just the steps how to solve a homogeneous differential equation. It will get very clear as we start with an example. So when we do the example, I will explain all the steps one by one. So let us start with the first example. Show that the given differential equation is homogeneous and solve it. So first thing is to show it is homogeneous. Again, as I told you, you can use any definition. So basically, you first of all express your function in the form of dy by dx. So dy by dx here is x square minus 2y square plus xy upon x square. First step is to show it is homogeneous. So in this function, since you are having x square in the denominator, you can take x square outside. As I told you, you can take x, y, anything outside, or you can take f of lambda x, lambda y, whichever is easy. So suppose if I take x square outside from numerator and denominator, it gets cancelled and I will get in the bracket a function in the variable y by x. So I could express fxy as x raised to 0 into g of y by x. So it is a differential equation, homogeneous differential equation. Why? Because it is of degree 0. So first step is done. Second step is now what you have to do is let your y is equal to v into x. That means your y by x, you have converted your function in the form of y by x. So your y by x, you take it as some another variable, say v. So v is equal to y by x means y is equal to v into x. So first thing is now here our fxy is 1 minus 2 into y square by x square means v square plus y by x means v. So our function is 1 minus 2v square plus v in the form of v. Second thing is what we have assumed is y is equal to vx. So suppose if I differentiate both the sides, it is dy by dx is equal to multiplication rule v into dx by dx, which is 1, plus x into dv by dx. Now remember this equation dy by dx is equal to v plus x into dv by dx will be same for all the examples if you use this technique. Okay. So now what we have is dy by dx from 1 and 2, just equate both dy by dx. So you will get 1 minus 2v square plus v is equal to v plus x into dv by dx. Next step is like we have done in the previous video, I had shown just take the terms having x on one side and the terms having v on another side. So it is dx upon x is equal to dv upon 1 minus 2v square. So now as we have brought the terms having x on one side and v on another side, we will integrate both the sides. So integral dx upon x is log mod x. On the right hand side, integral dv upon 1 minus 2v square, you can express it in the form of integral dx upon a square minus x square. But since you are having 2v square in the denominator, you just take out 2. So just take half outside, it will be integral of dv upon half minus v square. So your a is 1 upon root 2. Just put the values and you will be getting half into bracket 1 upon 2 into 1 upon root 2 log of 1 upon root 2 plus v upon 1 upon root 2 minus v plus c. Now next step is after simplification you again put back y by x as v as y by x. That means wherever there is v, just put y by x. So it will be log of mod x plus c is equal to, c is a constant, you can take it on any side. Log of mod x plus c is 1 upon 2 root 2 log of 1 plus root 2 y by x 1 minus root 2 y by x. So your final answer is 1 upon 2 root 2 log of x plus root 2y upon x minus root 2y is equal to log mod x plus c. Second example, show that the given differential equation is homogeneous and solve it. X dy by dx minus y plus x into sine of y by x is equal to 0. So first step is dy by dx expressed in the form of dy by dx. So dy by dx is equal to y upon x minus sine of y by x. Correct? So now this is very simple. In this case, directly you can write dy by dx as some function g of y by x. That means it is homogeneous. Now second step is same thing as I told in all the examples. You just need to take y by x as some variable v. So y is equal to vx. So you will be getting v plus x into dv by dx is equal to dy by dx. Now just equate both dy by dx and bring the terms having x on one side and v on another side. So what you are getting is dx by x is equal to minus dv upon sine v. Now see, we bring the terms of x on one side and v on another side. So have integral dx upon x is equal to minus of integral dv upon sine v, which is minus integral cosec v dv. You know integral of cosec x dx is log mod cosec x minus cot x plus c. So we can write log mod x is equal to minus of log mod cosec v minus cot v plus some c1. Now what I am going to do is c1 also, c1 is any constant. So log c1 again, say it is some another constant, say c. So basically we will have log mod x plus log of cosec v minus cot v is equal to right hand side log c1. So you can now write it, log can be taken out by taking the exponent. So now you can write, you know, log of x into y is log x plus log y type. So now you can write left hand side as x into cosec v minus cot v and right hand side as some constant c. So basically we are removing log. Now you put v is equal to y by x. Again re-put v is equal to y by x. So you get x into cosec y by x minus cot y by x is equal to c. Just simplify it. You will get x into 1 minus cos y by x is equal to c into sine y by x. This is the solution. Example 3. For the differential equation, find the particular solution satisfying the given condition. Means in this example, you have to find the particular solution. Till now we have found the general solution. In that, find the value of constant c to get the particular solution. The equation is x sine square y by x minus y into dx plus x dy is equal to 0. And the boundary conditions are y is equal to pi by 4 when x is equal to 1. So first step is try to express the equation in the form of dy by dx. So this you have to do the simple simplification. You are getting dy by dx is equal to y by x minus sine square y by x. So this is obviously a equation in y by x, homogeneous equation. Now same procedure, put y by x is equal to v. So y is equal to xv. When you differentiate, dy by dx is v plus x dv by dx. Now equate both dy by dx. So you get y by x minus sine square y by x is equal to v plus x dv by dx. Same procedure. Take the terms having x on one side and v on another side. So you get dx by x is equal to minus dv by sine square v. Now dx by x integral is log mod x and 1 upon sine square is cosec square. So integral of cosec square is minus cot. So minus of minus cot means plus cot. So the answer is log mod x is equal to cot of y by x plus c. So we have obtained the general solution, which is log mod x is equal to cot v plus c. And when you put v is equal to y by x, it is cot y by x plus c. Now our conditions to obtain the value of c. Y is equal to pi by 4 when x is equal to 1. So when you put x is equal to 1, cot of pi by 4 is 1. You know that. So 0, and obviously log 1 is 0. So 0 is equal to 1 plus c. C is minus 1. So you get log mod x is equal to cot of y by x minus 1. Cot y by x is equal to log mod x plus 1. When you bring 1 on this side, 1 you can write log e with the base e. Correct? So you know log of x plus log of y is same as log of x into y. So cot of y by x is log x into e. So your particular solution given the condition is cot y by x is equal to log mod ex. Another example in which you have to find the particular solution. 2xy plus y square minus 2x square dy by dx is equal to 0. Given is y is equal to 2 when x is equal to 1. Same thing, express in the form of dy by dx. So you get dy by dx is equal to y by x plus half y square by x square. So this is a homogeneous equation since you can write the right hand side in the form of some function of y by x. Next, put your y by x as v, that means y is equal to vx. So you get dy by dx is equal to v plus x dv by dx. Equate both dy by dx. So it is y upon x plus half y square by x square is equal to v plus x dv by dx. Put y by x again as v. So you get v plus half v square is equal to v plus x dv by dx. So now when you bring x and x on one side, v on another side, you get integral dx upon x is equal to 2 into integral dv by v square. So your answer is log mod x is equal to minus 2 upon v plus c. This is the general solution. Now put v is equal to y by x, again resubstitute it, and then you put the boundary condition. So log mod x is equal to minus 2x upon y plus c. When you put x is equal to 1, y is equal to 2, you get c as 1. So your particular solution is log mod x is equal to minus 2x upon y plus 1, or 2x upon y is equal to 1 minus log mod x, or y is equal to 2x upon 1 minus log mod x. This is your answer. Now also note one more thing, that suppose if you write log mod x plus c is equal to minus 2x by y. You know c is a constant, it can take any value, you can write it on any side. In that case, if you put the values, you might be getting the value of c as minus 1. But again when you put the value of c, resubstitute it, the last answer will be the same. So no problem. Your answer will be the same. Y is equal to 2x upon 1 minus log mod x. I hope the method of finding the solution of a homogeneous differential equation is clear. In the next video, we are going to see one more method of solving differential equations. Do like and share the video and subscribe to the channel. Students, the links to the other videos on differential equations are given in the description box.